So remember, when our bases are the same, what do we do with our exponents? We do not multiply them. When we're multiplying bases that are the same, we do what? We add them. So this is x to the 2 plus 3. So this is x to what power? This is y to what power? This is b to what power? And this is w to what power? Remember, if there is no exponent, we assume it is 1. Very good. One rectangle has length 12 inches and width 8 inches. A second rectangle has length 16 inches and width 2 inches. How many times greater is the area of the first rectangle than the area of the second rectangle? So area. What do we do to find our area? We multiply our length times our width. Remember, when we put letters next to each other, it means that we're multiplying them. If we have the letter next to a number, it means that we are multiplying them. So our length times our width of our first is 12 times what? 8 divided by the bottom, 16 times 2. Well, I can start like canceling right away. This 8 goes into itself once, and it goes into this twice. 2 times 2 is 4. What is 12 divided by 4? 3. 12 divided by 4 is 3. So the area of the first is 3 times greater. And showing your work is a good enough explanation for me. All right, go ahead and tuck that back into your folder. Scientific notation, that's where we're going today. We did a little bit of exploring on the computer. We also, I believe, looked at a little bit of these cards, but let's read through them again. So numbers that do not contain exponents are written in standard form. So standard form is just our regular number, normal, standard, basic. However, this is page 43 of the packet that we turned in the first 42 pages up. Yes, they're all over here if you need them. You should just see the whole packet there. You'll have to pull off the front where you are. That one.
Just that one right there.
Exponent. I did have a few extra that didn't have a home. I can hear. Some of you might have accidentally turned it in. Here's another scientific notation. This one looks to be missing a few though. Yes. What's that? No, that's long ago. I mean, yeah, marking period's over. Recycle it or hold it for reference. All right, everybody know where we are now, page 43. Page 43. It's really like the first page. Are we all good now? Do we need to, do you need a stapler back there? What is going on? Okay. All right, when you work with very large or very small numbers, it can be difficult to keep track of the place value. So scientific notation is a compact way of writing very large or very small numbers. That must be on my screen. That looks awful. All right. So scientific notation is a way of expressing a number as the product of a factor and an integer power of 10. When the number is positive, the factor must be greater than or equal to 1 and less than 10. So symbols for positive numbers written in scientific form, a times x to the n power, where A is greater than or equal to 1 and less than 10, and n is an integer. So integers, remember from our review, what are integers? Any whole number and its opposite. So what's the opposite of 3? Negative 3. What's the opposite of 84? What's the opposite of negative 10? 10. All right. We're getting there. Examples. So we might have a very big number. Remember, we would write it as 10 to a positive integer. And if we had a very small number, we would write it as something times 10 to the negative power. Standard laws, I need you to be helpful back there. All right, page 44. Are you with me still? We have to determine whether each of these is written in scientific notation. This is 44. Is this one written in scientific notation? I hear yes and I hear no. Well, what is it? Maybe. Well, is this number, is A bigger than or equal to 1? Yes, it's bigger than 1, but is it less than 10? No. So we have to say no. Remember, we should only have one digit to the left of the decimal. How about this second one? Yes or no? No. Yes. This number is greater than or equal to 1, right? And less than 10. So we would say yes. How about the third one there? Yes or no? Yes, it is. And the last one? No. It is not greater than or equal to 1. All right, so here's our first example. Write 5.34 times 10 to the 4th in standard form. So we write the power as a product. That's our first method. Do you see how they're giving us multiple methods? 10 to the 4th power is 10 times 10 times 10 times 10. So what is that? How many zeros? 1, 2, 3, 4. So 5.34 times 1, 10,000. And then we multiply. When we multiply, we move the decimal to the right that many times. So I would say, I could put it into my calculator, right? Or I can move the decimal, which is what they're going to show us next. So let's put this one into our calculator here. So 5.34 times 10,000. Not on details. Times 10,000 is equal to 53,400. So 5.34 times 10 to the 4th equals 53,400. Well, the other method is to move the decimal point. So moving the decimal point one place to the right is a result of multiplying by a number 10. So when you multiply a number by 10 to the 4th, the decimal place moves 4 places to the right. So that exponent is telling us how many places our decimal moves if our base is what? If our base is 10. If our base is 10, our exponent tells us how many places our decimal moves. So the exponent on the power of 10 indicates the number of places. In this case, how many places? 4. A positive exponent indicates the direction to the, am I moving it right or left? Right. A positive exponent tells us we're moving it to the right. So 5.34 times 10 to the fourth, well, the decimal was right here. So if we move it over 1, 2, wait, that doesn't make sense. If we have 5.34, where did those zeros come from? Where'd they come from, William? Yeah, so we don't actually have those zeros, right? 1, 2, 3, 4. We have to put them in. We can add as many zeros as we want to behind the decimal. It doesn't change it, right? Bless you. All right, so it's still 53,400. So you have two methods. You can write it out and use a calculator, or you can move the decimal. Which method do you prefer? Moving decimal or using your calculator? Any preference? Anyone? William? Moving decimal? Anybody like using their calculator? Some of you? Okay. So do this one, write it in standard form. So first I'm gonna rewrite my number, and then I'm going to move my decimal. How many places to the right would this one go? Our exponent tells me how many places, and it's positive, so it's going to the right 5 times. So try that. Should only take you a moment. It helps me to actually draw it out and see that it would go 1, 2, 3, 4, 5. What do I have to add here? 2 zeros. So then when I rewrite my number so that I can read it, I count back 3, and I have 993,100. Okay? Questions so far? So far, so good? All right, moving right along here. Example 2. This is very similar, except what do you notice about our exponent? It's negative. So really, we are going to be dividing by 10. When we have a negative exponent, remember it goes under the fraction bar, so we're dividing by 10. So they wrote the power as a product. So -1 plus -1 plus -1 would give us that -3. And then they flipped them because our negatives need to go to the basement. Let me know where we are. We're on page 45. Good, okay. Wasn't sure if you came in. All right, and then we're dividing by those things. So you would really be putting into your calculator, see they rewrote it for us, 3.27 divided by 1,000. So if I put that into my calculator, 3.27 or 3 27/100 divided by 1,000, I would get, oh look, they left it in scientific notation. That was so rude. See how they wrote it? 3.27. When it goes up there, it's saying times 10 to the -3. Either my calculator is in scientific notation form, or that's how it's going to give it to us. So 3.27 divided by 1,000. Yeah, it's going to give it to us in scientific notation. So you got to know how to do it. So this is going to move over 1, 2, 3. So it's 0.00327. All right, same thing here. We can move the decimal point. That's what I did to find it because our calculators don't show it. When you divide a number by 10, the decimal point moves 1 place to the left. So dividing by 10 is the same as multiplying by 10 to the -1st. So when you multiply a number by 10 to the -3, the decimal moves 3 places to the left. So -3 means 3 places and left. What tells us left or right? The positive or the negative, right? And the number donates how many, or notates how many places. Scientific notation, it's notating where to go. The exponent on the power of 10 indicates the number of places. In this case, how many places? 3. And a negative sign on the exponent indicates the direction. Negative sign tells us we're moving to the left. So I would rewrite RA, right? Whatever we're multiplying by the power of 10. And then we're moving 3 places to the left. 1, 2, 3. And again, I could put as many numbers in front of this and it wouldn't change the number. It would still be 3 and 2700. But your answer would be the same as we got up there. Questions so far? Okay, so positive means we're moving to the right. Negative means we're moving to the left. And if it's a base of 10, we can follow those rules with how many our exponent is. So check this one. I'm going to rewrite it 6.02 times 10 to the negative 4th. Check your understanding. Which way are you moving the decimal? The same way we moved it above, right? It's negative, so we think to the left of the number line. So we move our decimal to the left. And how many places? 4. So 4 tells us how many, negative tells us to the left. 1, 2, 3, 4. I need to fill in some places with zeros. And then I'm rewriting my decimal. So 602 tens, hundreds, thousands, 10,000, 100,000, millions. 602 millions. So we have to know what these mean. I believe. Oh, this is a pretty big section. All right, excellent. So I want you to do 1 through 4 on page 53. Numbers 1 through 4. This checks your understanding. Yeah, I know this was a pretty big section. Oh, just 1 and 2, sorry. We'll move on to 3 and 4 in a minute. I was getting ahead of myself. Just check those real quickly. Oh, Xander, that is not gonna work. All right. I'm gonna pay a little catch up. I always start by rewriting. What does the 3 tell us? It's on a base of 10, so it tells us how many we're moving the decimal, and it's positive. So which way are we moving it? To the right. How many places are we moving it? 3 places to the right. Let's try it. 1, 2, 3. What do I need to fill in? 2 zeros. So 1,600 would be my answer. Is that what you got? All right, what does the negative 7 tell us? We're moving to the left. That's the negative part of it. And how many places? 7. So I start by rewriting the number and I'm moving 1, 2, 3, 4, 5, 6, 7. So that is 1, 2, 3, 4, 5, 6 zeros before the 149. So tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. 149 billions. That's crazy town. So you could rewrite it a little more neatly. 1, 2, 3, 4, 5, 6, 1, 4, 9. Okay.
You don't actually have to add that to the number as
Yes, unless some of our numbers here, right. Some of our numbers here, we just will have to pay attention to when we're moving it to the right. Yeah. For sure. All right. Hop back to example 3. This is on page 40. Probably on page 45. Yeah, it's 46. Okay, so scientific notation and technology. We just saw this in the calculator. It says we're going to watch a video to learn how to interpret scientific notation. So when let me move this over here. Make it a bit bigger. All right. So when I share this with you. All right. So let's launch that real quickly. We have launched it. We've looked at we've explored, we've learned, we did examples 1 and 2. All right, this is where we should be. All right, let's check it out.
Graphing calculator and scientific notation. A calculator will convert numbers to scientific notation, only if they are very large or very small. Enter 8 followed by 11 zeros, then press enter. The calculator displays 8E11. The E11 means multiplied by 10 to the 11th power. So the value after the E symbol represents the exponent on the power of 10. So 8E11 means 8 times 10 to the 11th power. Try a very small number by entering a decimal with
Right on your
13
paper.
decimal places. Then press enter. The calculator displays 2.5E-12. This means 2.5 times 10 to the negative 12th power. You can also use your calculator to enter a number in scientific notation. Start by clearing your calculator. Type 2.389 times 10 to the 16th, like this. 2.389. Then press the second button. Next, press the EE button, which is written as EE above the comma button. Notice that it says EE on the calculator itself, but you will only see an E on the screen. Then type the exponent 16.
Okay, so it looks a little bit different on your scientific calculator. So these were the 2 things that we were filling in. So hopefully you caught on and we're following along slightly there. Now, when I put in that first one, 8 with 11 zeros behind it, it came out like this. I don't know if you can see that very well, but it says, got the 8, and do you see there's a little x10 there? So times 10 to the 11th power. So that's what it looks like on this calculator. And the way that you would do it on your scientific calculator is you could put in 2.5. Now, the second button is like the shift button here. I'm going to hit shift so that, do you see the stuff in yellow is 10 to something. And then I'm going to put negative 12. and see how it comes out to 2.5 times 10 to the negative 12. So it looks a little bit different here, but here's your 10 to the power of something. It's on your log. So if you hit shift, then it's that yellow button. And we'll have a little bit of chance to be practicing with those calculators today as well. Okay. So calculators often use, I'm just looking at example 3 now. Calculators often use the E symbol to indicate scientific notation. The calculator screen shows the approximate wavelength in meters of violet light. So step 1 is to represent the number on the calculator in scientific notation. So 4e to the negative 7th is really 4 times 10 to what? 10 to the negative 7. All right, so then we would write the number in standard form. We move the decimal point how many places? 7 places to the right or left? To the left because it's negative. So what if we don't see our decimal? Do you see a decimal if I wrote the number 4? We assume that it's right here. This is our decimal. We have to place it if we just have a whole number, right? Without any decimal yet. And then we would move it 7 places to the left. 1, 2, 3, 4, 5, 6. And like AJ said, it is 1 less 0. So did I miss one? Yes, I did somehow. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oh, one more. 7. There we go. So it's 1 less 0 than our exponent when we're moving in the negative range always. So that's what it would look like. Okay. Questions about how they're using E to represent 10 to a certain power. Just think of it as a base of 10 if it says E. So that we're gonna check here on page 47. The calculator screen shows the diameter of a grain of sand in inches. Which numbers represent the number shown on the calculator screen? Select all that apply. So remember, this is 2.4 times 10 to what power? The negative 3rd power. So 3 says we're moving it 3 places, and are we going left or right? Left. So we're going 1, 2, 3. Where do we see this number? All right. So is this 2,400? No. Is this 24 10 thousandths? Yes. Yes, it is. Is this 2.4 times 10 to the positive 3? No, we just said it is 2.4 times 10 to the negative 3. Is this 2.4 raised to the negative 3 power? No. That E tells us it's being multiplied by a base of 10 to that power. Okay? So do you see how we got those two for answers? All right, now you should be able to check numbers 3 and 4 on page 53. So hop to 53, guys, you're doing great. A calculator screen shows a number in scientific notation as 8.3e negative 6. Write it in standard form. Same thing here, 7e to 11. Write this number in standard form. Start by writing it in exponent form. This is 8.3 times 10 to what power? The negative 6. Now write it in standard form. Write it as a regular number. And then follow the same process with the other. Take a minute to do this. Hopefully we can figure these out rather quickly, right? The 6 tells us we're going 6 places, and that tells us to the left. So 1, 2, 3, 4, 5, 6, and just like AJ said, we know that there should be one less zero than our exponent if it's negative. So there should be 5 zeros. 1, 2, 3, 4, 5, 8, 3. 5 zeros and then 8 and 3. So we would read it as 83, tens, hundred thousands, 10,000, 100,000, millions, 10 millions. 83 10 millions. A calculator screen shows this number. Well, first write it as in scientific notation. 7 times 10 to what power? 11. Well, if our decimal's right here, how many zeros am I adding on to the 7? 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So every 3 I can put a comma to help me read this number. This is thousands, millions, billions, 700 billion. So please leave your watch away. Okay. So now we're gonna look at examples 4 and 5 and 6 and 7. Let's keep moving. So I'm hopping back all the way to page, I believe, 40. Well, let's look at 47, the bottom of 47. It'll help us a little bit. When writing a positive number in scientific notation, the sign of the exponent can be determined by examining the number in standard form. So if it's greater than or equal to 10, then the exponent in the power of 10 is positive. So if it's greater than or equal to 10, it's positive. If it's between 0 and 1, then our exponent is negative. So we are going to go in the reverse way. We're going to take a number now and write it in scientific notation. We've been taking scientific notation and writing it in standard form, and now we're taking standard form and writing it in scientific notation, okay? We have to switch gears slightly. So let's talk about it. If the number in standard form is greater than or equal to 1 and less than 10, what is the exponent on the power of 10 when the number is written in scientific notation? Think about that for a second. Would we multiply a number between 1 and 10 to get that by 10? So if I had the number 5 and I wanted to write it in scientific notation, we would say 5 times 10. 5 times 10 to what power? 5 times what equals 5? 1. So how do I get 10 to the power of something to equal 1? What exponent would I raise it to? 0. There you go, light bulbs. I saw all those light bulbs. So 5 times 1 equals 5. So what is the exponent on the power of 10 when the number is written in scientific notation? 0. So do you see how we kind of had to take a hypothetical, right? When a number is between 0 and 10, and put an actual number to it. Well, how would I write the number 5 in scientific notation? 5 times 10 to the power of 0. How would I write the number 6? 6 times 10 to the power of 0, right? We don't usually use them for those because it's not a really big or a really small number. That helps you to understand. All right, page 48 with me, please. Write 3,725,000 in scientific notation. This is page 48. So first they're telling you to write the number as a product. Well, they put a decimal just to the right of that first number. And we know it is in millions, so they multiplied it by 1,000,000. Well, how many zeros are in 1,000,000? 6. And this number is greater than 10, so it's gonna have a positive exponent. So 3,725,000 written in scientific notation is 3 and 725 thousandths times 10 to the 6th power. Now, if you wanted to check to be sure that was right, you could move this over 1, 2, 3, 4, 5, 6 times, and you would find that it was 3,725,000, right? All right, so which expression represents that in scientific notation? So first, where do we put the decimal? Right after this first 8. So it cannot be letter D. Is our exponent going to be positive or negative? Positive, because this number is bigger than 10. So it can't be letter C. We're checking between A and B. Well, how many times do we have to move this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it A or B? A. All right. Does that make sense? Do you want an extra check? We can share screen and hop over. There should be an extra example here for us. Where did we go? No, right here. We only have 3 minutes, so let's finish.
Graphing calculator.
Hey, where are you? Trying to get rid of you. All right. So let's skip to example 4. Extra example. Remember, these aren't written in your packet, so you'll just want to write it down. So if I was writing down 14,000, I'm sorry, 14,000,000. 14,140,000. This is a great ending spot. 14,140,000. So where am I putting the decimal? After this first one, so 1.414. Now, how many places would I move it? I'd move it 1, 2, 3, 4, 5, 6, 7. So times 10 to what? Not negative, positive 7. All right, so tomorrow we'll look at the other way in reverse, because we're going to be having numbers between 0 and 1.